Hi, everybody. Thanks for joining in. I'm Alexandra, Senior Product Manager for Data Science and AI at Seldon. And today we're going to speak about the explainability, why it matters, review toolset that we are developing at Seldon, and also look at the Anchor method. We also have a special guest, Jordan, who is Senior Data Scientist from Kaveh, insurance company, and he will share insights about how explainers bring value to their business. If you have any questions, let me know in the chat. First things first, why apply explainers? Models being used for different tasks, such as automation decision or discover certain patterns. And like any decision-making tool in organization, a certain degree of accountability is needed for ML models as well. Model explainability is important in environments that are regulated and monitored. And for example, machine learning in banking may automate the screening of loan or mortgage application. And the reason why loan applicant was rejected is important for the applicant and for the business, as financial decisions are often monitored. Another reason is that machine learning models are learning straight from the data, as opposite to the rule-based algorithms where developer or policymaker control with the guidance. It's often that data capture certain elements or patterns, such as decision bias of judgments that have been made before, or selection bias that causing the imbalance of the data set. And because model will learn directly from it, the decisions that model is providing is also capturing these biases or patterns that we want to eliminate. And this is particularly difficult with more complex machine learning techniques, such as deep learning, and understand why the model provides specific output may be initially unclear for data scientists, for non-technical stakeholders as well. So to process the process of explainability helps the human specialist understand the algorithm behind the decision, understand why this decision or the output have been made. And the model can also be explained to end user, to non-technical business stakeholder. So it is very important part of the creating machine learning models and putting them into the production. And now I'm going to share the methods that we are developing at Seldon. And now I'm going to share the library Alibi Explain that we're developing at Seldon. It's open source library, and it addresses, there are a couple of methods that are very handy. So the explainers are differentiated by whether it provides the global insights or the local insights. For example, if you want to explain one single instance or like the request to the model, then you use the local methods. And if you want to explain the whole data set, all of the requests, then you use the global insights methods. We have multiple methods, as you can see in the table, and all of them are documented, and there are tutorials and hands-on examples how to apply them. When you attempt to select which type of the explainer do you want to apply to your project, first of all, you need to think about the task type. It can be classification or regression. And then also what data modality do you want to use? It can be tabular, numerical, and categorical. It can be text, image, or complex data set. So you're selecting the data type. and the scope, which is the local or global explainer. And hopefully it already will help you to select one or two methods. And for today's demo, I will use the Anchor method. This is the hands-on tutorial of how to use the alibi explain Anchor tabular method, and also how to see it in Seldon deploy, the product that helps to deploy model at scale. And I will focus on these two parts. So there's a transaction data. Like first of all, we need to install the libraries and download the methods that we will use. The data set that is here present is a transaction data set with steps that are represent 1 hour, and this data set is containing 30 days of data points, different types: payment, transfer, cash out. We will filter it to transfer and cash out, and also other columns that describe the balance before transaction, after transaction, and the column that is defining was it fraud or not. The use case for this tutorial is whether this payment transaction was fraud or not, and to have some intuition of the data set. Here is a couple of here I will show the couple of plots. One, the first one show that on the y-axis there is a time, and in the genuine data set you will see the patterns, and it might represent the time when the business was closed, such as holidays or non-working hours. And for the fraud data, there are a mix of data points, no pattern, and it looks more chaotic. Another pattern is that in a general data transaction, we can see that amount of transaction is not kept, while in fraud there is a the certain limit from which it didn't grow. For the model training, we are going to use XGBoost classifier, and I will skip this part because it's like the training data with setting the weights, and go straight to the explainer. To use the explainer, first you need to set the prediction function to use the alibi explain library. After you after you create the function and specify the columns of your data set, you create the explainer. In this case, it's a Anchor tabular explainer. You feed the prediction, you feed the columns, and it generate the explainer object. Then we want also to balance data set, because in the original way how the data set was created, it was 0.3% of the fraud data and the rest was genuine data. So we want to make sure that we have a 50-50 in this data set to see how explainer will work. And after the data set is sorted, then you feed the explainer with the data set and with parameters, and that's basically the output. Once explainer is trained and you feed your data set, you can start sending the requests. In this example, we provide the random index, and we want to see whether the data point is normal or fraud, and we print the prediction, and we also print the anchor values and precision and coverage. So this is the explainer method in the notebook, and also I would like to demonstrate how it works in Seldon deploy. And there were a couple of steps that are required to build the deployment itself. So I will return to the model training. When we train the model, we save the model. We save it to the Google storage, and then once we want to put the model in the deployment, we create the cluster and create the deployment setting with name, location, with preparation server, specifying all of the metrics that we want to use. And then we create the deployment. With created deployment, then we can put the metadata, also adding the prediction schema as well. By doing that, we created the deployment. And again, this notebook will be available. And I'm going very fast on this section because this workshop is about the explainers. So here we are created the explainer as it was here. And we put this explainer to the deployment that was created in this notebook as well. And now we can see that when we send the request with the data set in the UI, you will see that we provide the data itself, the prediction output. Most likely this case was the fraud. And we also show the precision and coverage. I would like to speak more about the precision and coverage and what kind of insights can you read from these metrics. Coverage is answering the question, how general is the anchor rule? The coverage represents the proportion of the neighbors, neighbor data instances. So imagine you have the data and you have the nearby data set as well, and you want to understand if you can apply the same rule to this neighborhood area, and if with a higher coverage, the larger proportion of the data instances will be applied to the same anchor, and it means that this anchor provides the general rules. And similarly, if the coverage is small, then it means that rule is applicable to just small proportion of the data set, and there will be more rules that are smaller, but covering different instances. The precision is a proportion of the data instances sampled on the applied anchor, which has the same prediction labels. It might be example of the prediction label is a fraud, and we want to see the data points that are predicted as fraud as well. A high precision means that the anchor return for the data instance X, as an example, is applied to another data instance Y, and that it's very likely that Y will receive the same classification label as X. So imagine we have two data points, and a high precision will mean that if this data point is classified like this, then this one will classify with the same prediction. And thus the higher anchor precision suggests that the anchor is strong indication of receiving the same classification label as explained data instance. In the deploy, you can predict by sending the request, and here we have example of the request selected, and then predict, and we have the prediction. So imagine it's in real time, and you want to know the answer for this particular use case, and then you go to the request and see their results for the explanation. It will take some time to come back with the results. As Another example of the anchor, and maybe it will like bring more insights because it's like the very understandable picture. Here's the anchor calculating the part of the image. This part of the image is the anchor. So, and once it's detected in other pictures, the image will return the classification that it is a dog. And another example from our documentation is if you want to classify for example, you want to explain prediction for this pullover, and the model returned that, yeah, it's a pullover, so it's all good. And then explainer, the anchor, returned this part as explanation why it was classified as pullover. So it's just this part of the leaf. And that being said, that explains are very helpful in providing insights of why this data point was classified like this, but it also helped to check, well, actually, the model will give the pullover outcome for any picture with this anchor. And maybe the model, like, we want to change the data set, maybe we would like to diversify the data set with like different angles for the pullovers. So it actually will need to see the pullover to not only the part of the leaf. This example is available in alibi documentation for the anchors, and there are more tutorials for different data modalities. And it would be great if you're interested, to run this notebook to see how you can apply the detectors, explainers, and deploy model to production. So it will be in Seldon IO workshop at the fraud detection notebook, and I will share this link in the materials. Hi, Jordan. You recently won British Claims Awards for Counter Fraud and Insurance Times Fraud Solution of the Year. Congratulations.
Thank you very much. Yeah, we're increasing the award stack at Cover, especially in the data science team. So yeah, it's great to see.
It's always a good sign that the data science bring more awards to the company.
Yeah, definitely, and value as well. Definitely a good thing.
I know that you use explainers, and can you share why does it matter to you, and what value does it bring to the project?
All right, yeah. So explainability of algorithms is taking more and more a central place, I think, in that data science industry at the minute, the data science realm. And I feel like we know that algorithms that are created at the minute and used, such as XGBoost, LGBM, are very powerful. And we know they assist us with very many tasks within insurance, but in general, such as classification, regression, and we can do fraud detection, etc. However, I think more and more questions are being asked about the prediction and how it's been done, such as, is it ethical? Is it affected by bias? And is it used for the right reasons? And I feel like explainers are a crucial part of an organization in building confidence within their AI models and putting them into production. And I feel like AI explainability also helps the organization adopt a responsible approach to AI. In particular, within the financial sector, is the utmost importance that we are able to associate the cause to a cause to effect, and how you came to a particular conclusion. And this can be done using explainability. I believe in the future we will see more regulations around how AI machine learning is regulated. So therefore, explainability is going to be at the forefront of that, and it's very important. Yeah.
And which type of explainers do you use? Do you use any particular method?
Yeah, we use SHAP as the main method of explainability. We've researched into SHAP, and we find the SHAP framework has proved to be the most important advancement, in my opinion, in machine learning model interpretation. SHAP combines several existing methods to create intuitive, theoretically sound approach to explaining predictions and models. Um, so we looked into different techniques for explainability, such as LIME. However, we found that SHAP covered the widest variety, such as global and local explanations. I believe like the analysis using SHAP and other tools is an integral part of machine learning pipeline.
Absolutely. And would you say that it also helped to improve the way you develop the models by understanding which features have the most importance? And
Yeah, for sure. By making machine learning model explainable, it sort of aims to answer like many different questions, but some of the main ones are: why did the model make a certain decision? What were the features that affected the model's success or the failures? And what degree of confidence must the model have for you to be able to trust it? So I think explainability is a key part of being able to distinguish value from features within a data set. And we've used it extensively within all our models that we create, and as just one way of determining how important features are.
yeah, definitely. Do you have any tips to share with engineers, or maybe examples?
Yeah, sure. I think to start off with, I guess the understanding the importance of using explainability even after the model has been created, using explainability to assess how the model is performing, not just through code and assessing it by yourself, but also human intervention. Get the business involved in looking at these explanations, i.e., showing the business the results and helping them understand why a model is outputting a certain result the way it is. We find in many cases that the model variables would output a result that the domain experts didn't even um, pick up on, purely because it's correlated through the data. And this doesn't mean that just because the domain experts haven't picked up on it, it's not right and it's not justifiable through explainability. I feel also if some people are starting off with explainability, they look into the use of global and local explanations, not just global. I feel like a lot of people just look at the explanation from a general point of view. I have a few things I can share on screen.
Awesome.
Here we have an example of explainability within our fraud detection. This is where we do global explanation, but also local explanation. And as I said before, it's good to distinguish between the both. We use batch processing within our fraud detection. And as you can see here, we have feature importance graph that we show our end customer. This graph basically shows how important each variable was, or the most important variables were within a certain batch, not just a global explanation or a single explanation. So we're showing how important the variables that caused this batch to output the predictions it did within to our end customers. Following on from that, this is a more generic approach and straight out of the SHAP package, where we just created the SHAP visualization. A more untraditional approach we've actually implemented is a more tabled structure to how we actually show our SHAP explanations. So as you can see from here, we've actually created a table and a layout that's more easily interpretable by the end user. For example, we would extract the SHAP values for a particular feature, show the end user the actual values for that and the actual prediction value that has been associated to that using SHAP. This is for the top propensity fraud that we have actually outputted. Now, we've actually color coded it to show them not just what positively influences fraud, but also what negatively influences it. So, for example, what has weighed it in the opposite direction, so that they can have an understanding of why that particular fraud prediction actually has got the propensity that it got in the end. So this is a more untraditional approach to actually visualizing SHAP values, as well as just showing them on a graph. It's more user friendly, I would say.
Yeah, it's definitely helpful to separate and almost build two groups, clusters of features that has positive and negative influence to the outcome.
Yeah, definitely.
Thanks a lot for sharing and bringing the insights. Again, congratulations with awards, and wish you many more.
Thank you very much. Hopefully we can get a full cabinet.
Jordan, thanks a lot for joining this workshop and bringing the use case. Hopefully it was useful for you too.
Yeah, it was absolutely fantastic. Thank you for having me. And yeah, it was a really good workshop. Thank you very much.
Thanks a lot for joining, and please ping me if you have any questions, and if you want to have the links to the materials, we're happy to share. We have lots of open source product and lots of tutorials where you can learn more about explainers and other components. Thanks a lot.